On July 1st, 2025, telescopes around the world detected something impossible, an object hurtling toward our sun at over 245,000 kilometers per hour. They named it 3I Atlas, only the third confirmed interstellar object in human history. But this mysterious traveler carried secrets older than Earth itself. Scientists estimate it's over 7 billion years old, 3 billion years older than our own planet. Within hours, SETI telescopes locked onto it, scanning for any artificial signals. And a chilling question began to spread through the scientific community. What if this ancient wanderer isn't arriving by chance? What if it came here because it heard us? For over a century, humanity has been broadcasting radio waves into the darkness of space. And now, something was finally coming from that darkness, straight toward us. The evidence would shake everything we thought we knew. Prepare yourself. The story begins now. The NASA-funded Atlas Survey telescope in Chile was the first to raise the alarm. Automated systems flagged a fast-moving anomaly on July 1st, an object following a completely unnatural trajectory, a path that could only have originated from outside our solar system. Within 24 hours, follow-up observations confirmed the truth. Humanity had just encountered its third interstellar visitor, but this time, something was different. Unlike Oumuamua in 2017 and Borisov in 2019, this new arrival, 3I Atlas, behaved in ways no one could explain. Its orbital eccentricity was measured at 6.141, the highest ever recorded, so extreme that its path appeared almost perfectly straight, like a cosmic bullet fired directly at the sun. Then came a discovery that made astronomers uneasy. Amateur astronomer Sam Dean revealed that Atlas had been visible weeks earlier, from June 5th through the 25th. But its presence was overlooked, because it moved across the brightest region of the Milky Way, hiding among billions of stars. It was almost as if the object had been concealing itself. Coincidence or intelligent design? By July 2nd, observatories across the globe confirmed faint cometary activity, a glowing coma, and the hint of a tail forming as sunlight struck its icy surface. The Minor Planet Center officially designated it 3I Atlas, marking it as the third interstellar object in human history. Within hours, 122 observations poured in from 31 observatories across 6 continents. The world's top scientists were mobilizing. Fast. Dr. Simon Steele of the SETI Institute went live with astronomers Dr. James Davenport and Dr. Ariel Grakowski. Their message was clear. This was not just another space rock. Unlike Oumuamua, which was discovered after it had already passed the sun, 3I Atlas was spotted on its inbound journey, giving us precious months to study it. Even more astonishing, it was traveling in a retrograde orbit, moving backward compared to every planet in our solar system. Its path was tilted 175 degrees off the ecliptic plane, as if it were coming from the opposite direction of everything else. And at its closest point to Earth, its relative speed was 98 kilometers per second, nearly 100 times faster than a bullet. Astronomers around the world could feel it. This was something different, not just another comet or frozen relic, but maybe the oldest object ever discovered. A team from Oxford, led by Matthew Hopkins, estimated its age between 7 and 14 billion years, older than most of the stars in our galaxy, possibly as old as the universe itself. We weren't just witnessing a visitor from another star system. We were staring at a piece of cosmic history, a fragment that may have watched galaxies being born. Now racing through our solar system at over 245,000 kilometers per hour, 3I Atlas is officially the fastest object ever recorded by humankind. But as it draws closer to the sun, one haunting question remains. Was this just a rock from the stars? Or something that has been watching us? For a very, very long time, the object follows a hyperbolic trajectory, its eccentricity measured at 6.141, far exceeding the previous record holder, 2I Borisov, which reached only 344. To understand just how extreme that is, consider this. Our fastest spacecraft, Voyager 1, travels through interstellar space at roughly 61,000 kilometers per hour. 3I Atlas moves more than 4 times faster than humanity's most advanced probe. This staggering velocity creates a relative speed difference of 98 kilometers per second between Earth and the approaching object. At such speeds, any human intercept mission becomes completely impossible with current chemical rocket technology. The mathematics alone leaves scientists awestruck. Researchers calculate that 3I Atlas has been drifting through interstellar space for millions, perhaps hundreds of millions of years. During its endless journey, it was flung across the galaxy by countless gravitational encounters, each one acting like a slingshot that boosted its momentum higher and higher. Every pass near a star or stellar nursery added speed, until the object achieved the extraordinary velocity we see today. When astronomers traced its motion backward through the galactic coordinates, the results became even more fascinating. Upon entering our solar system, 3I Atlas was moving away from the galactic center with a velocity of -51 kilometers per second relative to the Sun, while simultaneously rising 18.5 kilometers per second upward through the galactic plane. This vertical motion is unusually high compared with nearby stars and other interstellar travelers, suggesting that Atlas follows a tilted, inclined orbit around the Milky Way. That tilt places it within what astronomers call the thick disk population, a vast, ancient region of the galaxy filled mostly with older, metal-poor stars. Because of this connection, astrophysicist Matthew Hopkins and his Oxford team estimated the age of 3I Atlas to be somewhere between 7 and 14 billion years, making it possibly older than the Sun itself, perhaps even older than our galaxy's youngest arms. But its speed also exposes something unsettling about cosmic mechanics. According to Asta Taylor at the University of Michigan, objects like 3I Atlas are not rare visitors. They pass through solar systems constantly. Hopkins estimates that roughly 80 objects the size of Oumuamua sweep through Jupiter's orbit every single year. They are simply too small and too fast for us to notice, unless one happens to pass dangerously close to Earth. That realization leads to a chilling thought. How many high-speed wanderers have already passed through our solar system unseen? The upcoming Vera Rubin Observatory may soon answer that question. Once fully operational, it is expected to detect at least one interstellar visitor every year, and perhaps dozens more traveling through the distant outskirts of our system before solar heating ever activates their cometary glow. If that happens, we may discover that 3I Atlas is only the tip of an interstellar iceberg, a first glimpse into a universe crowded with ancient, fast-moving relics that can approach from any direction at any time. Its record-breaking velocity is more than a statistic. It's a wake-up call to humanity, a reminder that our solar neighborhood is far from empty. Yet one haunting mystery remains. What could possibly accelerate an object to such unthinkable speeds? And why does its trajectory appear so precise, almost aimed? 3I Atlas now joins the exclusive club of interstellar visitors, following 1I Oumuamua in 2017 and 2I Borisov in 2019. Each of those encounters puzzled astronomers, but 3I Atlas shatters every pattern its predecessors set. Early estimates suggest this comet could stretch up to 20 kilometers wide, making it more than 100 times larger than Oumuamua. Such enormous scale contradicts every model predicting the typical size of interstellar debris. And unlike its earlier counterparts, which appeared relatively inert, 3I Atlas displays complex, active features that hint at internal energy and transformation. Images from the Hubble Space Telescope reveal a teardrop-shaped dust cocoon flowing outward from the nucleus, evidence of ongoing material ejection. Meanwhile, the Rubin Observatory recorded the coma expanding noticeably during a 2-week observation period, with the nucleus alone spanning an estimated 11.2 kilometers. Even more perplexing, their data show a dusty tail pointing directly toward the Sun, the exact opposite of what comets normally do. Typically, solar radiation pushes tails away from the Sun, but 3I Atlas seems to be ejecting dense, heavy particles that are too massive to be influenced by radiation pressure. This defiance of physics leaves astronomers questioning everything they know about comet behavior. Whatever 3I Atlas truly is, a relic, a messenger, or something beyond our understanding, its presence is rewriting the rules of interstellar science and reminding us just how little we truly know about the forces roaming the dark between the stars. The strange inward-facing tail of 3I Atlas defies everything we know about comets. Instead of being pushed away by sunlight, its dust flows toward the Sun, a direction that suggests deliberate ejection of material, not passive solar heating. And the timing of its discovery makes the mystery even deeper. Oumuamua was first spotted only after it had already passed the Sun, speeding out of the solar system on its way back into the void 2I Borisov was also detected late in its journey, leaving scientists with only a brief window to study it. But 3I Atlas breaks this pattern completely. It was discovered months before its closest approach, long before its October 29th perihelion, giving humanity an unprecedented opportunity to study an interstellar visitor while it's still on its way in. The discovery instantly reignited old controversies. Harvard astrophysicist Avi Loeb, who once suggested that Oumuamua might be an artificial probe, returned to the spotlight. Back in 2018, his theory of an extraterrestrial origin was dismissed by most scientists as pure speculation. But Loeb and his colleagues are now arguing that 3I Atlas displays even stronger evidence of a technological or engineered origin. To them, its motion, structure, and peculiar dust emissions seem far too deliberate to be random. Of course, not everyone agrees. Many astronomers caution that the apparent rise in interstellar detections may simply reflect better telescopes, not an increase in cosmic traffic. According to Matthew Hopkins, countless smaller interstellar fragments likely pass through our solar system every single year, invisible to our instruments unless they happen to pass very close to Earth. That's why the upcoming Vera Rubin Observatory is so crucial. Its next-generation scanning system is expected to find at least one interstellar object per year once it's fully operational. Every new visitor adds a missing piece to our understanding of galactic motion and cosmic history. While Oumuamua and Borisov came from entirely different regions of space, 3I Atlas appears to originate from the thick disk of our Milky Way, a massive, ancient layer of stars that formed billions of years before our Sun. That origin alone suggests that 3I Atlas has been roaming the galaxy for billions of years before its chance encounter with our solar system. And when viewed as part of a larger pattern, from Oumuamua to Borisov, and now to Atlas, an unsettling escalation emerges. Each new visitor grows more complex, more active, and far stranger than the one before it. It's as if something out there is sending a series of progressively clearer messages through the dark spaces between the stars. What then is 3I Atlas trying to tell us? Scientists estimate with 67% confidence that the object is older than 7.6 billion years. For comparison, our Sun and solar system are only 4.5 billion years old. That makes 3I Atlas potentially the oldest object ever observed by human science, and possibly as ancient as 14 billion years, reaching back to the dawn of the universe itself. The implications go far beyond ordinary astronomy. If true, we are witnessing something forged during the earliest epoch of creation, a living fossil from the birth of the cosmos. This age estimate comes from its motion and composition, both of which tie it to the Milky Way's thick disk, a vast vertically extended region populated by the galaxy's oldest and most primitive stars. Its vertical velocity, about 18.5 kilometers per second relative to the Sun, confirms that it belongs to this ancient stellar population. Stars in this region contain far fewer heavy elements than those in younger, thinner disks, meaning they formed back when the universe had barely begun creating metals. In other words, 3I Atlas was born when the cosmos itself was still young, when the first stars were forging the heavy elements that would one day make planets, oceans, and life possible. Over those billions of years, 3I Atlas has been shaped by countless gravitational encounters, each one subtly altering its course, each one accelerating it through a cosmic slingshot effect. The longer an object drifts through interstellar space, the more momentum it accumulates. Its tremendous speed is like a cosmic odometer, recording eons of motion through a galaxy constantly in flux. But that realization raises profound questions. If this object truly dates back 7 to 14 billion years, then it predates the formation of nearly every known planetary system nearby. It could have been traveling through space when the first heavy elements were being forged in the hearts of exploding stars, long before Earth, the Sun, or even the Milky Way's spiral arms took their current form. Such an object might carry pristine samples of the early universe, untouched and unchanged since time began. UCLA astrophysicist David Jewett notes that tracing its exact origin is practically impossible, comparing the effort to seeing a rifle bullet for 1,000th of a second and trying to deduce where it was fired from. Computer simulations suggest that 3I Atlas may have come from a star system that no longer exists. Its parent star may have already died, collapsing into a white dwarf neutron star, or even a black hole. If that's true, the implications are staggering. 14 billion years ago, the universe was less than 1 billion years old. There were no complex elements, no rocky planets, just hydrogen, helium, and faint starlight. If 3I Atlas truly formed in that primitive age, it would be a direct sample from the universe's chemical infancy, a frozen record of the very processes that created matter itself. Its internal composition might hold the secrets of how the first elements were fused, how galaxies evolved, and how the building blocks of life began to spread across the cosmos. Every atom inside 3I Atlas could predate every atom in the human body by billions of years. We are, in essence, observing a time capsule from before Earth existed. That realization is deeply humbling. To gaze upon this traveler is to confront our own smallness, to realize that while life on Earth has existed for mere moments in cosmic time, this object has been moving through the dark for almost all of eternity. And now, for reasons we can only guess, it has arrived here, in our neighborhood, in our age. What cosmic secrets does 3I Atlas carry toward our young solar system? And is it merely passing through, or delivering a message older than life itself? Within hours of its confirmation as an interstellar object, the SETI Institute began an emergency series of monitoring operations. Under the direction of Dr. Wael Ferrer, chair of SETI's Allen Telescope Array, scientists launched round-the-clock observations, scanning for both narrowband radio emissions that might indicate an artificial signal and natural frequencies produced by dust and molecular compounds. Whatever 3I Atlas truly is, the search has already begun, and humanity waits, listening to the stars, for an answer. The sheer speed and urgency of SETI's response show just how seriously scientists are considering the possibility that 3I Atlas might not be natural. Within only 24 hours of the discovery announcement, the Allen Telescope Array began full-time monitoring on July 2nd. In less than a week, researchers had already gathered more than 21 terabytes of data, the equivalent of thousands of hours of high-definition video. This stands as one of the most comprehensive data collection efforts ever attempted to detect potential artificial signals from a celestial object. Every byte of that data is now under intense analysis. Teams are combing through it, searching for both natural radio patterns and potential techno-signatures, those subtle traces that could reveal the presence of advanced technology. Scientists are particularly focused on several indicators: radio communications, electrostatic bursts caused by sunlight striking metallic or artificial surfaces, and any evidence of controlled motion. If 3I Atlas were an active probe, it might attempt to adjust its path, realign antennas, or even stabilize itself in orbit, actions no natural object could perform. The ultimate proof, of course, would be a stable approach toward Earth, the kind of maneuver an intelligent observer might make to study our planet's life and atmosphere. But SETI's monitoring doesn't stop at radio signals. Major observatories, including the Vera Rubin Observatory, are running advanced spectroscopic scans to determine the object's true chemical makeup. If they detect rare compounds or materials not found in ordinary comets, substances resembling alloys, ceramics, or propulsion residues, it could point to something entirely beyond nature's design. Avi Loeb and his colleagues have even tied 3I Atlas to the dark forest hypothesis, the unsettling idea that intelligent civilizations stay silent, not because they don't exist, but because they fear being discovered by something far more dangerous. If true, 3I Atlas might represent a civilization that isn't hiding anymore. SETI researchers are also preparing for the unthinkable, possible communication attempts. Loeb suggests that if the object does prove artificial, humanity might consider sending a radio signal toward it during its closest pass. But he warns, contact could be risky. An alien intelligence might see such a message as a challenge, or a threat. Because of its proximity, any potential reply wouldn't take centuries. It could reach Earth within months. That's why Loeb's Galileo project has activated 3 observatories to track for any unusual aerial or orbital activity immediately after 3I Atlas reaches its closest approach on October 29th. Some believe it might even deploy smaller probes toward Earth or neighboring planets as it passes through the inner solar system. Now it's your turn. Comment where you're watching from and what time it is right now. And while you're at it, hit that like button and subscribe, because this story is only getting stranger. Stay alert, the universe is watching, and 3I Atlas may not be traveling alone. Harvard's controversial paper takes an unsettling turn, proposing that 3I Atlas might be the clearest evidence yet for the dark forest hypothesis. This chilling theory suggests that the galaxy is not silent because it's empty, but because it's full of civilizations that are hiding, concealing themselves from predators among the stars. The academic world reacted immediately and divided sharply. Avi Loeb points to several anomalies that defy natural explanation. Based on brightness and reflectivity, 3I Atlas measures an astonishing 20 kilometers across, over 100 times larger than Oumuamua, and far beyond anything predicted by current interstellar debris models. Yet, despite being labeled a comet, it shows no coma, no visible tail, no signs of the typical outgassing we expect when ice meets sunlight. Even 2I Borisov, another interstellar visitor, displayed active jets and vapor trails as it neared the sun. But 3I Atlas remains eerily inert, silent, dark, and perfectly composed. Then comes the trajectory, an even greater mystery. This object will pass Venus at 0.65 AU, Mars at 0.19 AU, and Jupiter at 0.36 AU, a series of precision flybys that are mathematically almost impossible by chance. The probability of these planetary alignments occurring naturally, just 0.05%. Loeb suggests that such alignment cannot be coincidence. It could indicate deliberate navigation, a planned series of encounters to study or utilize each planet's gravity. But the most haunting part happens when no one can see it. During its October 29th perihelion, 3I Atlas will slip behind the Sun from Earth's view, hidden completely during a perfect window for what scientists call a reverse solar Oberth maneuver. That's when a spacecraft uses the Sun's gravity to slow down or even stop its interstellar flight, a move that could capture it into our solar system's orbit. And the timing couldn't be more suspicious. The object reaches this ideal breaking point at the exact moment it's invisible to every Earth-based telescope. To some, that's coincidence. To others, it looks like intentional concealment. Naturally, many scientists are skeptical. Chris Lintott of Oxford University, part of the team modeling Atlas's galactic trajectory, called the artificial hypothesis nonsense on stilts, a dismissal echoed across much of the scientific community. Others argue that such extraordinary claims require extraordinary evidence, evidence that, so far, doesn't exist, but Loeb stands firm. He calls the paper a pedagogical exercise, a thought experiment meant to push scientific boundaries, regardless of whether it proves true. He believes the idea could reshape how we approach future interstellar objects, especially as the Vera Rubin Observatory prepares to discover dozens more in the coming decade. Loeb also points out a strange imbalance. Humanity fears terrestrial AI, yet barely discusses the risks of extraterrestrial intelligence. If the dark forest hypothesis holds true, then 3I Atlas could be something far more terrifying. Either a scout from a predatory civilization, or a refugee fleeing the aftermath of cosmic war. It's a sobering possibility. Civilizations too scared to speak, hiding in eternal silence. If that's true, then 3I Atlas may not just be a comet. It might be a message, a reminder that survival in this galaxy belongs to those who remain unseen. And yet, even as skeptics argue, the object's behavior grows harder to explain. Its trajectory doesn't just brush past one planet, it passes three: Venus, Mars, and Jupiter, each at near perfect alignment. Statistically, such precision has a probability of just 0.5%. NASA confirms 3I Atlas poses no danger to Earth, maintaining a distance of about 1.8 astronomical units, roughly 170 million miles. But its calculated proximity to the other planets feels almost too perfect, as if scripted. Dr. Marshall Eubanks from Space Initiatives reports that several spacecraft and Mars orbiters will have an unobstructed view during its approach, providing humanity's best chance to catch it in action. If it performs even the slightest course correction, the implications would be revolutionary. Even its 175-degree tilt against the ecliptic plane defies natural expectations, moving backward through the solar system, opposite the direction of every planet. That orientation aligns perfectly with planetary orbits, an alignment with a mere 0.02% probability. In other words, the odds that this trajectory happened by random chance are nearly zero. The Jupiter flyby presents an especially valuable window, NASA's JUICE mission and Psyche spacecraft may both be able to redirect instruments toward 3I Atlas during its approach, watching for any signal transmission or subtle maneuvering. Even a faint course change could rewrite everything we know about interstellar travel. For now, direct interception from Earth is impossible. At nearly 98 kilometers per second, 3I Atlas is simply too fast for any chemical rocket to reach. Even a flyby would occur at speeds above 60 kilometers per second, far too quick for clear imaging. But Mars offers a unique vantage point. While Earth's view will be blocked by the Sun during perihelion, Mars orbiters and surface rovers could capture what no Earth telescope can see: surface details, material composition, or even signs of engineered structure. The closer the analysis, the stranger it becomes. This object isn't just a rock from another star system. Its precision targeting, its retrograde orbit, and its timing challenge every model of natural motion. Whatever 3I Atlas truly is, comet, probe, or something we haven't yet imagined, it has already succeeded in one mission, forcing humanity to confront the haunting question of whether we are truly alone, or simply being watched. If 3I Atlas is indeed an artificial object, its trajectory suggests something extraordinary: a deep, calculated understanding of our solar system's planetary arrangement. The precision timing of its path implies long-term mission planning, accounting for planetary positions and orbital mechanics with near-perfect accuracy. Natural objects simply don't possess the ability to perform such intricate, multi-planetary maneuvers. Dr. Lowe warns that these close planetary approaches could provide ideal opportunities for 3I Atlas to deploy smaller probes toward individual worlds, and such deployments would be virtually impossible to detect from Earth. The probes would be too small and moving far too fast. The sheer mathematical improbability of this precision forces us to confront an unsettling question. Are we witnessing the most unlikely natural event in solar system history, or the carefully executed mission of an intelligent design? On October 29, 2025, 3I Atlas will reach perihelion, its closest point to the Sun, at roughly 1.36 astronomical units, positioned between Earth and Mars. But there's something even more mysterious. This closest approach will occur while the object is completely hidden behind the Sun from Earth's point of view. A perfect solar eclipse, blocking all terrestrial observation during the most critical phase of its visit. Even the Hubble and James Webb Space Telescopes cannot observe it during this period, as they cannot point toward the Sun's blinding glare. The timing feels suspiciously convenient. This eclipse window provides ideal conditions for performing a reverse solar Oberth maneuver, a propulsion technique where thrust is applied at maximum orbital speed to drastically change velocity. Unlike a normal Oberth burn, which accelerates a spacecraft for escape, a reverse burn slows it down, potentially allowing an interstellar traveler to become gravitationally bound to our solar system. The fact that this perfect braking opportunity aligns exactly with Earth's observational blackout is deeply disturbing. I-Atlas will remain invisible to ground-based telescopes through September 2025, emerging again by early December once it moves beyond the Sun's glare. That's a 3-month blackout, precisely during the period when any artificial object would likely perform its most critical maneuvers, or even deploy smaller craft. Typically, natural comets display dramatic outgassing when approaching perihelion, as solar heat vaporizes their icy surfaces. But for 3I Atlas, things are different. While Earth's telescopes can't observe it, several spacecraft across the solar system might keep watch. Mars orbiters and rovers will have unobstructed views during this hidden phase, possibly becoming humanity's only eyes on the event. NASA's Psyche mission and Jupiter Icy Moons Explorer could also monitor it from afar, tracking any signs of movement, signal transmission, or unusual behavior. This blackout creates the perfect cover for actions that would otherwise be instantly detected from Earth, such as probe deployment, course adjustments, or even signal transmissions directed beyond our system. If 3I Atlas is artificial, its operators could not have asked for a more convenient window of secrecy. To prepare, Dr. Lowe's Galileo project has assigned dedicated observatories to monitor for UAP, unidentified anomalous phenomena, activity immediately after perihelion. The plan is to detect any artificial objects that may have been released during this hidden phase, especially if probes were launched toward Earth or other planets. The timing of this event feels too perfect to be chance. Nature rarely offers such precise opportunities for concealment. If 3I Atlas was simply a wandering comet, the probability of its closest solar approach occurring exactly during Earth's blind spot would be vanishingly small. So what could happen during those 3 months when human eyes cannot watch? Adding to the mystery, 3I Atlas shows no clear signs of a typical cometary tail or coma. The glowing halo expected when icy materials vaporize near the Sun. Most interstellar comets, like 2I Borisov in 2019, displayed spectacular outgassing as they heated up. But for 3I Atlas, any such activity appears faint and inconsistent. Recent observations from the Vera-Rubin Observatory revealed something even stranger. The object's faint dust tail doesn't point away from the Sun, as expected, but toward it. This backward orientation defies standard physics, suggesting that heavy particles are being actively ejected in the Sun's direction, possibly by mechanical means rather than passive heating. Initially, astronomers weren't even sure whether 3I Atlas was a comet or an asteroid. Early observations in July showed no visible activity at all. Only later did multiple telescopes detect a weak, diffuse coma and a narrow tail, roughly 3 arcseconds in length. Researchers estimate it's ejecting fine dust particles at speeds of 0.1 to 1 meter per second, losing about 0.1 to 1 kilogram of mass per second, a rate far too steady and restrained for a typical comet of this size. In other words, 3I Atlas doesn't behave like a natural object at all. Whatever this interstellar visitor truly is, comet, artifact, or something beyond our current understanding, it's forcing humanity to confront one of the most unsettling questions of all. Are we being visited, or simply observed? Despite its massive size, 3I Atlas exhibits surprisingly limited outgassing, a behavior that defies expectations for an object approaching the Sun. Ordinarily, such substantial material ejection should create a bright, visible coma and a long, luminous tail. Yet the observed activity appears faint, almost restrained. This mismatch between calculated outgassing rates and visible emissions hints at something far more unusual. It could mean that the surface composition is not like that of normal comets, or that the ejection of material isn't caused by heat at all, but by non-thermal mechanisms, possibly mechanical or artificial in nature. Natural comets are rich in water ice and volatile compounds that vaporize easily under solar heating. But the subdued activity of 3I Atlas raises a critical question. Does it lack these materials entirely, or is it made from something else, something engineered? If its volatile compounds were long depleted after billions of years drifting through interstellar space, that would be remarkable in itself. But if it's constructed from non-volatile materials, resistant to solar radiation, the implications are far more extraordinary. Upcoming spectroscopic studies by major observatories may reveal whether 3I Atlas contains unusual compounds not found in typical solar system comets. If the spectra show rare or manufactured materials, it could point toward an artificial origin or formation under exotic conditions far beyond our galactic neighborhood. Even stranger, 3I Atlas seems far too quiet for its immense age. After possibly billions of years in the interstellar void, constant exposure to radiation and micrometeorite impacts should have hardened its surface, forming a crust that prevents outgassing altogether. Yet, despite this, it shows faint activity, inconsistent with what science would expect from such an ancient traveler. This lack of clear cometary behavior leaves astronomers puzzled. Without the familiar coma or tail, traditional methods for distinguishing comets from asteroids fail. Now, scientists must depend on indirect evidence, trajectory, reflectivity, and perhaps even radio signatures to decode its true nature. Atlas now sits in an awkward classification limbo, too active to be a simple asteroid, yet too quiet to be a typical comet. Early measurements estimate that its nucleus spans nearly 20 kilometers in diameter, over 100 times larger than Oumuamua, and vastly exceeding predicted sizes for natural interstellar debris. Dr. Asta Taylor from the University of Michigan notes that while determining its exact dimensions is challenging, observations place the nucleus between 11 and 20 kilometers across, making it by far the largest interstellar object ever detected. Images from the Vera-Rubin Observatory confirm its colossal scale. In deep exposure photographs, 3I Atlas transforms into a cosmic rainbow, a chain of glowing pearls streaking across the starfield. This vivid display surpasses anything seen with earlier interstellar visitors. Such immense size carries staggering implications. If 3I Atlas is a natural object, it defies current astrophysical models, as simulations suggest interstellar debris should be much smaller. If it's artificial, however, it represents technological engineering on an almost unimaginable scale, something capable of constructing a vessel the size of a small asteroid. A 20-kilometer wide structure could, in theory, house entire populations, resource facilities, or autonomous machines designed for deep space travel. Even if not inhabited, the sheer size implies capabilities far beyond our current technology. Spectroscopic analysis reveals that despite its scale, the object ejects fine particles, micrometer to millimeter-sized dust, at rates between 0.1 and 1 kilogram per second, with velocities of 0.1 to 1 meter per second. Such modest speeds are inconsistent with solar-driven outgassing for an object this massive, deepening the mystery even further. Astronomers are now questioning whether our previous models of interstellar visitors are simply too limited. Perhaps smaller objects pass through our system regularly, escaping detection. And 3I Atlas is merely the first giant we've managed to spot. The Vera Rubin Observatory's upcoming surveys are expected to revolutionize these statistics, revealing whether this is a rare anomaly or part of a hidden population of cosmic giants. David Jewett compared tracking 3I Atlas to catching sight of a bullet for 1,000th of a second. Except this bullet is the size of a mountain, moving through space at interstellar velocity. How can such a massive object achieve such incredible speed? The forces required to propel something this large between stars push the boundaries of our current understanding of astrophysical dynamics. If natural, it challenges everything we know about how star systems eject material. If artificial, then we may be witnessing evidence of engineering beyond human comprehension. Adding another layer of intrigue, the object's origin traces back to the Milky Way's thick disk, a region composed of the galaxy's oldest stars. Its motion, traveling at plus 118.5 kilometers per second relative to the Sun, confirms its membership among this ancient stellar population. According to Oxford University researchers, such objects are typically between 7.6 and 14 billion years old, meaning 3I Atlas could be as old as the galaxy itself. That makes it not just the largest, but perhaps also the oldest interstellar visitor humanity has ever observed. And as it moves through our system, it forces us to confront a haunting possibility. Is this massive silent traveler a relic of the galaxy's distant past, or a machine from a civilization that once was, or still is, watching us? The origins of 3I Atlas may trace back to one of the Milky Way's most ancient stellar populations, the thick disk. Researchers discovered this connection after carefully analyzing its galactic motion and velocity. When the object entered our solar system, it was already moving away from the galactic center at an astonishing 51 kilometers per second, a clear signature matching thick disk stars, not the younger, thin disk stars like our Sun. Thick disk stars formed billions of years ago, when the galaxy itself was still young. Their chemistry carries the fingerprints of an ancient universe. If 3I Atlas was born in that era, its composition could reveal traces of the earliest stellar materials, remnants, from a time before complex life even existed on Earth. Upcoming, spectroscopic analysis aims to confirm whether this interstellar traveler indeed carries those ancient chemical markers, the reduced heavy elements that define thick disk formation. If confirmed, it would mean 3I Atlas has been drifting through interstellar space for billions of years, a silent witness to the galaxy's entire history. Over this unimaginable journey, it's likely passed countless stars, planets, and nebulae, each gravitational encounter subtly altering its course and increasing its speed through cosmic slingshots. Every interaction left an imprint, like a cosmic odometer recording eons of galactic travel. Astrophysicist Chris Lintott and his team at Oxford used advanced simulations to trace 3I Atlas's path backward through time, hoping to find its birthplace within the thick disk region. But after billions of years of motion, pinpointing its exact origin is nearly impossible. As astronomer David Jewett explained, trying to retrace such an ancient object's path is like mapping a raindrop's origin after it's merged into the ocean. The implications, however, are staggering. If 3I Atlas were of artificial origin, it would mean intelligent civilizations existed in the thick disk, billions of years before our solar system was even formed. It suggests that technology and intelligence might have emerged far earlier in the universe than we ever imagined. The thick disk itself makes up nearly 2/3 of the Milky Way's stars, a vast, ancient reservoir of potential civilizations. But most of its stars have long since evolved, their planets destroyed or transformed as they became white dwarfs, neutron stars, or even black holes. If 3I Atlas originated there, its home system may have vanished eons ago, leaving only this object to tell its story. Its trajectory also explains why it was so hard to detect. Approaching from the direction of the galactic center, it blended perfectly against the dense background of stars, camouflaged by the very galaxy it came from. By the time it was spotted, it had already come dangerously close, giving us only a narrow window to study it. This realization forces scientists to confront the true scale of deep time, an object older than complex life itself, carrying secrets from the dawn of the Milky Way. Within just 1 week of observing 3I Atlas, the Allen Telescope Array gathered over 21 terabytes of data, one of the largest and most detailed data sets ever collected on a single astronomical object. SETI researchers are now scanning that data, searching for both natural and artificial signals, any sign that could reveal the object's true nature. Dr. Yael Farah leads this search, monitoring for every possible kind of emission, from radio transmissions that might suggest technology to natural signals from dust and molecular compounds. The dual approach ensures no possibility is missed, whether 3I Atlas is a natural relic or something far more advanced. Among the most intriguing possibilities are radio communications, electrostatic discharges from sunlight striking artificial surfaces, or even subtle course corrections, the kind an active probe might perform to stay in contact with its origin point. SETI's monitoring builds on decades of experience. Projects like Serendip and Breakthrough Listen have refined techniques to distinguish artificial patterns from the background noise of the cosmos. With their help, this search for signals from 3I Atlas is one of the most comprehensive in history. After all, Earth itself broadcasts a vast halo of electromagnetic energy, over a century of television, radar, and radio waves expanding outward for nearly 200 light years. If someone out there was listening, they'd already know we exist. Perhaps 3I Atlas is someone's way of saying, they've been listening too. The search for signals from 3I Atlas continues to captivate scientists worldwide. If this object truly carries technology, the clues would be unmistakable. Artificial signals tend to stand out, repetitive, narrow, and precisely structured. The kind of radio emissions nature doesn't produce on its own. But detecting them isn't easy. Transmitting across interstellar distances requires immense power and complex signal processing. Even the most advanced civilizations would face massive signal degradation as their messages cross the cosmic void. That's why sensitive instruments like the Allen Telescope Array, with its massive 34-meter dishes, are crucial. Only such systems can detect the faint whispers of intelligence from objects as distant as 3I Atlas. So far, no clear artificial signals have been found. But that doesn't mean they aren't there. The 21 terabytes of collected data are still being processed, a task requiring advanced algorithms and artificial intelligence capable of finding patterns too subtle for the human eye. Modern SETI programs rely on machine learning systems to sift through this cosmic noise, flagging anything that might bear the fingerprints of technology. Monitoring will continue as 3I Atlas approaches its closest point to the Sun, the perihelion. If it hides dormant systems, solar heating could awaken them, changing its radio behavior. Dr. Loeb's team plans to intensify surveillance after October 29th, watching for any sudden bursts of signal or unexpected movement that could hint at active control. For now, the silence is deafening, but silence doesn't mean absence. The dark forest hypothesis warns that advanced civilizations may deliberately hide their presence, staying radio silent to avoid detection by potential predators. If 3I Atlas belongs to such a civilization, it may remain quiet until its mission is complete. Those 21 terabytes of data might contain the truth, a discovery that could forever alter our understanding of life in the universe, but the mysteries don't end there. 3I Atlas follows a path that has left scientists stunned. a near-perfect alignment with the orbital plane of our solar system's planets. This phenomenon, called ecliptic alignment, is extraordinarily rare, with only a 0.2% chance of happening by accident. Its orbit is tilted just 5 degrees from the planetary plane, and even more curiously, it moves in retrograde, opposite the direction of every planet's motion. At its closest pass, 3i Atlas will reach a velocity of 68 kilometers per second relative to the Sun, while Earth moves in the opposite direction at 30 kilometers per second. That's a relative closing speed of nearly 100 kilometers per second, making interception impossible with current rocket technology. Even more puzzling, this alignment allows 3i Atlas to pass close to multiple planets during a single flyby. Within 0.65 AU of Venus, 19 AU of Mars, and 0.36 AU of Jupiter, the odds of this happening by random chance, just 0.05%. It's as if the object plotted a course designed to maximize observation of every major world in the solar system, a flight path fit for reconnaissance. If guided by artificial intelligence, it could be collecting data on planetary atmospheres, surface conditions, or even signs of life. And during these encounters, it could deploy smaller probes toward individual planets, gathering information from multiple perspectives simultaneously. The alignment also enables perfect observation angles for our instruments. While Earth-based telescopes may be blinded by solar glare, Mars-based systems will have clear visibility. Farther out, the Jupiter Icy Moons Explorer could capture the object from another vantage point entirely. Multiple observatories, positioned across the solar system, will watch as it passes, a once-in-a-lifetime opportunity to study this cosmic visitor. But the same alignment that aids observation also helped hide it. Approaching from the direction of the galactic center, 3i Atlas was buried in dense star fields, a natural camouflage that delayed discovery until it was already close. This short observation window leaves scientists racing against time. Even more intriguingly, its timing aligns with a 3-month period when it will pass behind the Sun, invisible from Earth. If it were to perform any maneuvers during that time, we wouldn't see them. A subtle deceleration could even trap it in a stable orbit, effectively capturing it within our solar system. Coincidence or calculation? Either way, 3i Atlas offers a masterclass in interstellar navigation, a trajectory so efficient that future space missions, like the European Space Agency's Comet Interceptor, are studying it for guidance. Whether this precision is the result of natural forces or deliberate design, it challenges our assumptions about what's possible. The perfect alignment, the improbable trajectory, and the mysterious silence all force us to choose between accepting cosmic coincidence or acknowledging intent. Nearly 50 years ago, in 1974, humanity sent its own message to the stars, the Arecibo transmission, directed toward the globular cluster Messier 13. Crafted by Frank Drake and Carl Sagan, it was our way of saying, "We are here." Perhaps 3i Atlas is the universe's way of replying. For nearly half a century, the Arecibo message has stood as humanity's most famous attempt to reach out to alien intelligence. But what if something was already listening, much closer than we ever imagined? Back in 1974, the Arecibo Observatory's 1 megawatt transmitter and its massive 305-meter antenna created a signal so powerful it could travel thousands of light years through space. The message was aimed at the M13 star cluster, nearly 25,000 light years away, home to about 300,000 stars. That means, even in the best case, humanity would have to wait 50,000 years for a reply. So, what if the reply doesn't come from that far away? Because Earth has been sending signals, by accident, for far longer. Our very first public radio broadcast happened on December 24th, 1906, and those signals have been expanding outward ever since. Today, that invisible sphere of radio and TV transmissions stretches nearly 200 light years from Earth, quietly announcing our presence to anyone listening. Any civilization within that sphere could have detected us decades ago. Our radio waves are unmistakably artificial, narrow, repetitive, and structured in a way nature never repeats. These emissions reveal exactly how a technological civilization introduces itself to the galaxy. Those waves have already reached over 100 nearby stars, including Vega, Aldebaran, Barnard's Star, Sirius, and Proxima Centauri. If intelligent life exists around any of them, they've been hearing us for generations, Now, here's where things become unsettling. What if something like 3I Atlas, that strange interstellar object, has been drifting through space for billions of years, wandering from star to star, and one day, it happened to pass through that expanding bubble of Earth's radio noise. At its enormous speeds, it could have been drawn by gravity toward our solar system, toward the very signals we've been leaking for over a century. Could we have accidentally called it here? The Arecibo broadcast wasn't humanity's only message to the stars. The Soviets once beamed coded transmissions toward Venus, spelling Mir, Lenin, and USSR in Morse code. Between 1999 and 2016, other deliberate signals were sent toward stars up to 69 light-years away. And now, scientists are preparing the beacon in the galaxy message, a new unified call combining all of humanity's earlier efforts to make contact. But there's a darker possibility. According to the dark forest hypothesis, advanced civilizations might destroy others before they become threats. If that's true, then our century of open broadcasting could have painted a target right on Earth. Maybe the wisest civilizations remain silent, not out of fear, but out of survival. If 3I Atlas is artificial, it might not just be a rock from another system. It could be a probe, scouting, observing, or even answering our broadcasts. Some researchers have even suggested trying to contact it directly, but warn that doing so could be extremely dangerous. Unlike the Arecibo message, which would take millennia to travel, 3I Atlas could reply within months, or even reach Earth by Christmas 2025. Maybe the Arecibo echo isn't coming from the stars at all, but from something that's been listening all along. In 1977, humanity launched Voyager 1 and Voyager 2, each carrying a golden record, a time capsule designed by Carl Sagan and his team. These records contained 116 images, greetings in 55 languages, sounds of Earth, and music representing our entire civilization. The spacecraft also bore maps showing where to find us, our cosmic address, engraved in gold. Both Voyagers have now left the solar system, drifting through the same interstellar medium that 3I Atlas has likely traveled for eons. Their faint signals take over 22 hours to reach Earth, proof of just how far they've gone. But recently, Voyager 1 began behaving strangely, sending garbled data back home, eerily mirroring the mysteries surrounding 3I Atlas itself. In March 2024, engineers briefly re-established contact, but the question lingers. Could both be part of the same story? One message we sent out, and one that's finally answering back? The decoded Voyager message revealed something remarkable. A complete readout of the spacecraft's flight data memory. It was enough for NASA engineers to finally diagnose the mysterious communication failures. But fixing it in real time, that's impossible. Each signal from Voyager takes 22.5 hours to reach Earth, and another 22.5 hours for Earth's reply to travel back. Almost 2 full days for a single exchange across the cosmic void. Yet, despite those limitations, Voyager's communication system stands as one of humanity's greatest engineering triumphs. Each spacecraft uses a 23-watt transmitter, about the power of a refrigerator light bulb, and a 3.7-meter antenna to send faint whispers across billions of miles. Received on Earth by 34-meter radio dishes, operating on S-band and X-band frequencies. The Voyager's data rates have slowed as they've moved farther away, but their connection to Earth has never been completely lost. These tiny signals prove what's possible, that interstellar communication doesn't demand brute power, but precision, patience, and design born of purpose. Before Voyager, there were the Pioneer missions, the first true ambassadors from Earth. Their iconic plaques, designed under Carl Sagan's direction, displayed simple yet profound images. A man and a woman, mathematical diagrams, and a pulsar map marking the sun's position. They were built to be universal, to speak a language of physics and geometry that any civilization could understand. Those same design elements later appeared in other human messages, like the cosmic call transmissions, a visual and mathematical fingerprint, a recurring signature of human thought, echoed across every attempt to speak into the silence. Both the Pioneer and Voyager spacecraft will continue their journeys for millions of years, drifting through interstellar space, long after Earth itself may be gone. They carry with them our sounds, our art, our music, our proof that we once existed. Carl Sagan described the Golden Record as a present from a small distant world, a time capsule of who we are. our science, our music, our laughter, and our hope. The final words engraved upon it read, "We are attempting to survive our time so we may live into yours." And now, as 3i Atlas approaches from the same interstellar void the Voyagers have entered, one can't help but wonder, have our messages already been heard? The golden records travel outward, while 3i Atlas moves inward, two ships passing each other in the cosmic dark, each carrying messages across an endless night. Launched in 1972 and 1973, Pioneer 10 and Pioneer 11 were humanity's first emissaries to the outer planets. After exploring Jupiter and Saturn, they continued outward beyond the solar wind, becoming the first true explorers of the interstellar frontier. Each carried a small metal plaque, etched with symbols, mathematics, and the image of humankind, our quiet introduction to the universe. Until Voyager 1 surpassed it in 1998, Pioneer 10 was the most distant human-made object ever launched. The Pioneer plaques displayed a pulsar map locating our sun, a hydrogen atom diagram defining universal measurement, and the naked human figures, the first representation of ourselves sent to the stars. Those designs weren't arbitrary. They reflected a profound belief that mathematics, physics, and the constants of nature form a common language, one that any advanced species could recognize. Every interstellar message since has built upon these ideas. From Pioneer's simplicity to Voyager's cultural depth, each step marks humanity's growing confidence in its voice across the stars. And now, with the creation of the beacon in the galaxy, we are combining all that knowledge, refining our message, unifying our call. But here's the irony. If alien civilizations sent out probes as small and slow as ours, moving at just 10 miles per second, they would be nearly impossible to detect. So perhaps they've already done the same. Perhaps 3i Atlas is exactly that. An unnoticed messenger, drifting quietly between the stars, crossing paths with our own. Our current detection technology can track objects as small as 10 to 20 meters, but only out to about Jupiter's distance. That means if an alien probe, similar in size to our own Voyager spacecraft, were approaching from interstellar space, we likely wouldn't notice it until it was already inside the asteroid belt. This limitation opens up a chilling possibility that countless small, interstellar visitors may already have passed through our solar system, completely unseen. The Pioneer and Voyager missions will continue their cosmic journeys for billions of years, each carrying humanity's earliest attempts at interstellar diplomacy, our first messages to whatever other minds might exist out there. They mark the beginning of our species' introduction to the galactic community, announcing our technological maturity and our peaceful intent. But now, as 3i Atlas approaches with characteristics that defy natural explanation, we must ask, have our cosmic postcards already been received and analyzed? If this interstellar visitor has truly been wandering the galaxy for billions of years, it could have encountered evidence of countless civilizations, perhaps even ours. The timing of 3i Atlas's arrival, coinciding with humanity's own era of space exploration and interstellar messaging, might not be a coincidence at all. Our Pioneer and Voyager probes continue outward into the dark, while something ancient and mysterious moves toward us from the same void. A meeting arranged across space and time, between the senders and the watchers. For over a century, Earth has been unintentionally broadcasting its presence to the cosmos. Since the first public radio transmission on December 24, 1906, our radio and television signals have been expanding outward, forming a growing bubble of electromagnetic radiation now 200 light-years wide. Those signals have already reached more than 1,000 nearby stars, including Vega, Aldebaran, Barnard's Star, Sirius, and Proxima Centauri. Any intelligent civilization within that sphere could have detected unmistakable signs of technology, clear, structured, and undeniably artificial. Unlike the random noise of the universe, our signals repeat, modulate, and carry patterns that reveal intention. Our very technology has made Earth visible to the galaxy, and once seen, we cannot be unseen. Even the natural distortions caused by Earth's atmosphere wouldn't be enough to mask the truth. We've been shouting our existence into the dark for more than a century. This makes us vulnerable, because in revealing ourselves, we also reveal our location, our level of advancement, and how quickly we're progressing. If intelligent life exists around nearby stars, they may have already intercepted and analyzed these signals decades ago. We became visible to the cosmos long before we realized it, And that brings us back to 3I Atlas. Its arrival now, at this precise moment in our history, raises an unsettling thought. What if its trajectory was not random? What if, over eons, gravitational encounters subtly redirected it toward us? Each close pass by a star could have shifted its path, guiding it ever closer to the source of artificial radio noise. Our noise. Our century of transmissions may have acted as an inadvertent homing beacon. Over the decades, the evolution of our signals has painted a timeline of human advancement. From crude radio broadcasts, to television transmissions, to satellite relays, and finally to deliberate interstellar messages, like the Arecibo broadcast. To an outside observer, it would tell a clear story of a civilization rapidly transitioning from industrial to interstellar capability. Our signal history is a map of our technological awakening, and our deep space network, with its massive antenna arrays and ultra-sensitive receivers, demonstrates just how capable we've become at listening across the stars. Ironically, these same tools that allow us to explore space also make us easier to detect. We have become a bright beacon in a dark forest. The dark forest hypothesis warns that the galaxy may be filled not with friendly explorers, but with silent hunters, civilizations that destroy potential threats before they can strike first. If that theory is true, then our century of open broadcasting may have already marked Earth as a target. While wise civilizations remain quiet, we've been announcing ourselves, loudly and without caution. Perhaps 3I Atlas is not a messenger, but a scout, a silent observer sent to evaluate us before a more direct contact, or something far worse. Astrophysicist Avi Loeb warns that any attempt to send radio communication toward 3I Atlas would carry enormous risk. Unlike signals aimed at distant star clusters that take millennia to return, a nearby visitor could respond within months. That makes this potential first contact not a distant dream, but an imminent possibility. And now, as Voyager 1 continues to transmit from over 24 billion kilometers away, having crossed into interstellar space on August 25, 2012, it drifts through the same cosmic realm that 3I Atlas may have traveled for billions of years. Voyager moves at 61,000 kilometers per hour, crossing roughly 523 million kilometers every year, about 1 light year every 18,000 years. It remains humanity's furthest voice, still whispering across the void. And somewhere out there, perhaps closer than we think, something ancient is listening. And now, it's coming closer. Recent communication issues with Voyager 1 have drawn eerie parallels to the mysterious approach of 3I Atlas. Since November 2023, the spacecraft has been sending back strange, unreadable data, long streams of alternating ones and zeros instead of its usual telemetry. NASA engineers described it as if they were still on the line with Voyager, but its familiar voice had been replaced by a flat, endless dial tone. What makes this especially unsettling is the timing. These signal anomalies began just as astronomers started tracking the inbound path of 3I Atlas, a coincidence that feels too perfect to ignore. Then, in March 2024, engineers finally made a breakthrough. They managed to decode fragments of the corrupted data and discovered a complete memory readout from Voyager's flight data system, including operational codes and internal status logs. However, communication remains painfully slow. Every command sent to Voyager takes about 22.5 hours to reach it, and another 22 hours for the reply to return. That means nearly 2 full days just to confirm a single response. NASA's investigation points to a likely cause, a malfunctioning chip inside the flight data subsystem, possibly damaged by radiation or simply worn down after nearly half a century in deep space. The damaged chip prevents Voyager from properly packaging its telemetry before transmission. While the technical explanation makes sense, the timing of these issues, aligning so closely with 3I Atlas's discovery, leaves an uneasy question hanging in the silence between the stars. Could it really just be coincidence, or is something out there trying to answer back? The decoded transmission from Voyager 1 revealed something extraordinary, a complete readout of its memory system, containing operational codes and detailed status reports. But even after this breakthrough, the communication struggles continue. Every signal takes 22.5 hours to reach Voyager, and another 22 hours to return. That means each command, each piece of feedback, takes nearly 2 full days to confirm. The problem, engineers say, began with a single failed chip, likely damaged by deep space radiation or worn out after nearly half a century of service. This tiny malfunction prevents Voyager from properly packaging its data before sending it home. The explanation seems reasonable, yet the timing feels almost too coincidental. Voyager's anomalies began just as a new interstellar object, 3I Atlas, entered our awareness. Could something approaching from the void be affecting our most distant probe? Voyager 1 now drifts through the same interstellar medium that 3I. Atlas has been crossing for billions of years, a vast ocean of charged particles and cosmic radiation that blurs the boundaries between solar systems. Voyager's instruments continue to study these very conditions, the same ones 3I Atlas has silently navigated throughout its cosmic journey. And in that shared environment, interaction or interference might not be impossible. Radio hobbyists on Earth have managed to detect Voyager's faint signals using simple equipment. In 2006, German operators even confirmed its transmission with a modest 20-meter dish, proof that Voyager's whisper can be heard by anyone who listens carefully enough. If amateurs can detect it, what could an advanced civilization do? Voyager's 23-watt transmitter, barely stronger than a cell phone, must rely on massive 34-meter dishes on Earth to capture its fading voice from billions of miles away. That fragile link could be disrupted by radiation, distance, or by something deliberately observing. Still, NASA's engineers press on. They're rewriting code, rerouting systems, and fighting to keep humanity's oldest explorer alive. Every adjustment takes days. Every success feels like a message of defiance from across the stars. But the uneasy overlap between Voyager's strange signals and the arrival of 3I, Atlas raises one haunting possibility, that something isn't just listening, it's responding. Voyager carries the golden record, humanity's message to the cosmos, a declaration of peace, culture, and curiosity, now drifting through the same darkness where 3I Atlas roams. One is our ambassador, the other, perhaps a reply. And as their paths converge in the endless night, one question remains. What if the silence between the stars was never empty, just waiting for an answer?